Once again, a slightly different filming location and a slightly different sound, but that's partly because of the camera I'm using. The camera I'm using is the Wiley Fox Swift, which I got some time ago, just to experiment with which phones were good for filming these videos. And watch this. I thought at the time that there's something wrong with the image. I've found what it is. It's got incredible zoom. And when you zoom right up, there's a slight image noise in it. Can you see the slight noise in the image? It's not that bad though. Other than that, it's quite respectable. It's got a very high resolution camera. Anyway, here is the device in question in this video, which is a water feature LED light from homestores. And it basically has a battery pack in the bottom, remote control, it's got LEDs, and it's got a watertight seal underneath, with possibly one of the more creepier aspects of it is the way the battery contacts are just mounted straight onto the circuit board. And the way they're mounted onto the circuit board, let me just zoom up here. The gap between these is really low. I mean, they don't really come close to touching, but it's just they're very close. I think they folded the metal back just for extra strength and to give it that sort of rigidity to stop it bending. And it seems okay, but they are very close. Now, when you first put the batteries in, it does this automatic function that it just turns into its default setting of flashing the lights, red, green and blue. I'm just going to zoom back out here again. The remote control offers the usual things. It lets you choose single colours and it fades. It doesn't just snap to that colour, it actually fades between them. And it's got a limited range of colours and various effects, including the flash one, which just basically whatever colour you've selected, it flashes it on and off. And you can change the speed of that. It's got strobe, which basically just pulses between different colours. I don't know if you'll even see this here. There we go, that's better. You've got fade. Oh, a little bit of pulse modulation showing there. I've not actually considered what the speed of this is. One moment, I'm just going to shake it violently off screen. It's fairly fast pulsive modulation. It's not too bad. And the other mode is smooth, which doesn't look particularly smooth at all. Any one of those colours, if you say, for instance, choose a colour like white, which is the highest current colour, then you can fade that down with the dimmer control. The dimmer control also controls the speed of the flashing and changing effects. If I click this while pointing it at the infrared receiver, it will fade down. And you'll see the pulse width modulation creeping in because it's got on, the LEDs are just basically on for a very tiny percentage of the time now. So I measured the current in this. Let's turn this off. I measured the current in this and it is as follows. The standby is a slightly high 0.4 milliamps. It doesn't matter if it's running on 3.6 volts as with nickel metal hydride cells or the fresh alkaline cells. It's about 0.4 milliamps, which is quite high. At full output, the highest current is with fresh alkaline cells on white is about 270 milliamps. It comes out to roughly 100 milliamps per circuit of LEDs. There are 4, 5, 6, 7, 8, 9, 10 LEDs. So therefore, I'm guessing all these 50-50 style package LEDs have all the chips wired in parallel for each color. These are the current settings. I'll let you just browse them, but it certainly goes from at the lowest intensity on the white, the highest output color, it goes from just 4 milliamps at that setting I had there, right up to about 270 milliamps. And it means that, if you do like a color, you can extend the battery life greatly because you can see the current drops off rapidly when you use the little dimmer function. So you can extend the battery life greatly just by running it at a lower intensity. And with the 3.6 volts, it is by default going to be a lot dimmer and it's going to draw less current. So nickel metal hydride cells might be an option here. But anyway, I think it's time. He said stand up. I'm at an awkward filming location. I'm having to stand up and kneel down. That's why you hear the voice change quite a lot. Let's open it up. That's what we do. So this thing has a metal plate at the bottom. That's not a magnet. It's just purely metal plate to weigh it down because this thing is designed to be submerged underwater. And it's got an O-ring seal round here. So when you tighten this up nice and snug, it does theoretically make it completely waterproof. There are 2 screws in here. There's a position for a third one that is not occupied. Wonder why they left that one out. Lazy manufacturing, or just they decided maybe they only needed two. The ubiquitous 8-pin chip. Oh, and a little bit of foam in here. What's that? Is that to hold this? Oh no, it's probably to hold this white shield. Would that look nicer without the shield? I think it would actually look quite nice without the shield. Where's the keying arrangement? I think that would go in that way. How would it look? Well, it looks quite stylish without the without that white panel. But the white panel is maybe going to act as a reflector and also add a sort of cosmetic appearance to it. So let's zoom in moderation, since this camera has ruthless zoomability. And I've just whacked the shelf that this is on, so it will stabilize shortly. What we have here is the ubiquitous 8-pin chip. I don't see anything on that, which is not really surprising. It tends to be a generic microcontroller. We've got the infrared receiver and we've got 3 transistors, and that's about all we're getting here. I think the little resistors here look like the current limiting resistors for the LEDs, and those ones here are the current limiting resistors for the bases, if those are standard NPN type transistors, which I'd guess they may well be for the microcontroller. And the rest of the circuitry is really just a few support components around here, mainly sort of pull-up and filtering components for the infrared receiver to make sure it's stable. The LEDs are all in parallel, by the look of it, yes, because they've got one side of the 6-pin package is just common to the battery. Let's see, what side is that common to? Common to battery positive, which makes sense, and that means the negatives of the LEDs will be switched down via these, presumably an NPN transistor. I don't have my magnifying glass with me, which is a bit annoying. I didn't think about that. I started traveling about and just, I should have picked up the spudger. I should have picked up the magnifying glass. I just completely forgot to do that. But it is a fairly textbook arrangement. It's about as simple as they could make it, with just the generic 8-pin microcontroller, a standard infrared receiver, and 3 transistors for very standard 50/50 package RGB LEDs. Is there much else to say about this? This will be the absolutely standard little remote control. Everything about it is what you'd expect. What is quite interesting is the collimating reflectors here, which are designed to cup over the LEDs and just direct the light out forwards a bit. I'm not sure how much of an effect that has, because the LEDs in their own would tend to splash light out quite widely, because they are, let's put the battery in and check that, because they are 50/50 LEDs, and that's what 50/50 LEDs do. It's a very, very common package. Well, the WS2812B type program LEDs come that style. Yeah, it just splashes light out in all directions. Looks quite psychedelic. It's quite a nice light. It's quite pleasing. The 0.4 milliamp current drawn standby is quirky, but it's not a big issue. It just means that you can't leave it in storage for a long period of time. If you leave the batteries in it, you are better taking the batteries out and just put them in when needed. But quite a neat little device.